Hi, I'm going to discuss about the topic mining products and its features. The problem statement is that we have to extract the products and features out of the GDPR corpus, which is the corpus which we have chosen. This particular problem has been troubleshooted in various ways, like the ones which we see on the screen. Mining products and attributes is currently done using the click similarity, document similarity, and distributional similarity. The common theme from all the three methods is it tries the products and the attributes are mined based on the user click logs. The problem or the limitations of these particular methods is the sparsity of the click logs by the user. User may choose to use different kinds of words to address the same product, and the user clicks are sparse based on the information available on each link. Our approach is to extract the features and products from a standalone blog and or a review, and it includes a machine learning trained model which has been trained on the annotated text. Our approach primarily includes two stages. The first stage is extraction of primary entities, and the second stage is extraction of features. The extraction of entities is done in the following way. The text is passed through the natural language processing tools available in number of online processing tools, natural language processing tools like Stanford NLP, Code NLP, or Open NLP, etc. Hence, the text is annotated with the POS tags, NER tags, and co-reference resolution tags. So, after the text is annotated with these particular things, we apply a few semantic rules which extracts the entities and the primary entities. For extraction of entities out of the annotated text, we do the following thing. So as you can see on the screen, Volkswagen Beetle has a super fuel efficiency and great design. The fuel efficiency is a feature, and Volkswagen Beetle is the product. As we can see from the pointer on the screen, the Volkswagen and the Beetle both are proper nouns. This particular feature, like the products are usually the proper nouns, and consecutive proper nouns denote an entity. So this particular feature is used to extract the entities out of the text. So how to extract all the entities from a text, and for that we have used this particular feature of proper noun and the frequency of repetition of this particular word across the text. Blogs usually refer to this particular entities or products n number of times across the text while discussing about the features. So by gathering the features of this particular proper noun entities, we have gathered the following parameters. So as you can see from this particular result, the thrush, javelin, clifford, AMC, and gremlin are the primary entities or the entities which are recognized using the proper nouns, and their repetition across the text is given by the repetition count. So we observe that the majority topics are usually repeated the most across the text, and along with this particular frequency repetition features, we have also used a co-reference list, wherein which each word we have highlighted here is also repeated or co-referenced in various ways. Like criminal is called by my first gremlin, Mexican gremlin, the gremlin, etc. So these are various synonyms available for gremlin. So by resolving these particular synonyms, we increase the particular count of AMC, gremlin, etc. All the words which we can see from the text highlighted below. So by the number of times a word occurred in the text, we resolve that these are the primary entities of discussion across a blog or a text. Sometimes along with the primary entities of interest, like in this particular case the cars or the car companies, there are unwanted topics such as thrush or sometimes a name of a person. For resolving this particular conflict, we have used knowledge bases available such as DBpedia, wherein which the multiple texts are passed through the knowledge base using a Sparkle query. We query the particular DBpedia and it returns back with the category of each word. The categories for a particular word maybe like it can be like for example, for a car it can be car organization, automobile, and a company. So these are the categories for a company. So by extracting all the categories for the words which we have for the primary entities which we have found, and trying to get the majority of the categories, we can remove the odd one out of the primary entities extracted. So this is how we extracted the primary entities. And next, moving to the topic of extraction of features. As seen from the previous example, the primary entities have dependents which can be seen from the collapsed CC dependencies. For example, the fuel efficiency is one of the features, and it has dependents. The dependents are called as the governor and the dependent. Here, for example, the governor is a verb which is has, and the dependent of fuel efficiency is nothing but superb. So from this we understand that we can define a feature based out of a rule where the particular feature is usually a noun, and it has a governor which can be a verb, and a dependent which can be an adjective, and they are referenced by modifiers such as a mod and the object. So by this method of manually trying to extract the rules, we may be able to extract the features, but the problem is such rules has to be framed across a corpus for each and every sentence. So we have tried to use machine learning techniques like decision trees and decision rules to extract the features from the particular text. So how could we do the feature extractions from this particular sentence? We gathered the word, its pass of speech, its NER, name entity recognition, and its dependence parts of speech and any recognition in a particular table, which can be seen here. So these are the various features which we have gathered. These features are passed into the machine learning algorithm like decision tree. In our case, we have chosen a JRIP machine learning algorithm. From that, we are able to extract the following.